What's up, guys? This week we are learning about radical expressions. Today's the 17th of February, and I'll be teaching you how to solve this problem right here. The cubed root of 40x to the 4th and y to the 7th. Okay, so first let me teach you some vocabulary terms before we go on with this problem, because these terms is something you gotta know in order to solve them. So right here, this right here is called the index. The index tells us how many x's or y's or the prime factors of 40 we're allowed to take out. This right here is called a radical. So a radical, I'll explain this in a moment. And inside of the radical is the radicands. This 40 is a radican, x to the 4th is a radican, and y to the 7th. These are all radicands. They're the terms inside of the radicals. Radicands. Alright, now let's get within the problem now that we know some vocabulary. My second step right here, I will be showing you that the first thing we gotta do to solve this is prime factor to 40. So prime factors are very easy. It's basically what times what will equal 40. We could go 22, we can go like 10 and 4. We can go 8, 5. There are just many ways to do it, whichever way you think is more comfortable for you. Personally, I don't care which one I'll choose. I'll just do 20 and 2 for now. So 22, 10 multiplied by 2 will give it to 20, and 20 multiplied by 2 will equal 40. That's how we get this. That's how you know which numbers to take out. And right here, what times what will give us 10, 5 and 2 will give us 10. Now let me show you over here. We'll get the same answer. 5 and 2, 2 and 2. 4 and 2. I'm sorry about this is getting messy. But you see, we still have the same numbers. Except it's in different form, but still the prime numbers, they're still going to be the same. 5, 2, 2, 2. And 5, 2, 2, 2. And 5, 2, 2, 2. This 2, I'm going to circle all the prime numbers. Prime numbers are what's going to be in the 40. Because if we went 5 times 2, let me show you right here. Oh, my bad. Okay, 5 times 2 is 10. Then you go multiplied by 2 is 20. Then you go multiplied by 2 is 40. When you multiply all of the prime numbers, it will equal 40. That's why we take out these prime numbers. We're going to put them in the radicand. So right here, my third step, now that we got the prime factors, we're going to use this index and pull out the prime factors and the x's and the y's. So 5 times 2 times 2 times 2. I like to write them out. It just helps me. But you know what? There's another way. You can go like this. Let me adjust the camera. 3 the root of 5, and you can go 2 to the 3rd. Let me show you how this way is handy. I just don't use it because personally I want to be organized. So you go 1, 2, 3, 4, then 1, 2, 3, 4, 5, okay, 6 and 7. It's gonna be messy. Sorry, I have to fit everything. So 7 y's will be established, 4 x's. We can use one of these x's and it can become x cubed and x to the 1st. I'll explain why we did this. Because the x cubed multiplied by x to the 1st, when we're multiplying exponents with exponents, I should say, we add the exponents. When we're multiplying numbers, we add the exponents. So let me show you. X cubed multiplied by x to the 1st. It's going to be x to the 4th. We add these. 3 plus 1, 4. We use the same variable. That's what I established. That's what I'm saying. This is a rule you got to know. Very important rule. You know, you might find all the answers, you might find it, but if you don't know this rule, you cannot get the answer. This rule is very important. It could come in a test. I've seen it many times in my test. Like a very simple question, then all of a sudden if you don't know the rule, you can get the problem wrong. So study this. It's very important. Alright, now when I look at this, this might look complicated, but this is actually a simple problem. Like, again, as my teachers say, hard problems are just simple problems stacked up together. So now we use this index, 3. This is the 3rd root of all these numbers. So we use this index and we say, how many 2's are there? There are 3 2's, so we're allowed to pull out 1 2. This is 1 right here, 2 and 3. This gives us 1 2, so we're allowed to pull it out of the radicand and pull it out of the radical, my bad. So right here we put a 2 right here. How many 5's are there? There's only 1 5. We cannot do anything. 1 5. So if we had 2 more 5's, we're allowed to pull out a 5. So since this is going to be, there's only 1 5, we're not allowed to pull anything because the index is 3 right here. So you cannot. X's, 4 X's, 1, 2, 3. We got to pull out 1 X. We're left up with another X. Just like I explained with the 5, this is going to be extra. How many Y's? We have 7 Y's. 1, 2, 3. This is 1. 1, 2, 3. This is 2. 2 Y's. We're allowed to pull out 2 Y's because we pulled out 3. 3 there and 3 there. So 2 Y's. So it's going to be Y times Y. So Y squared. That's how we know. We're left off with 1 extra Y. See, 1 extra here, here, and then there. As I said, it's messy. I'll show you right here. This is a much quicker way. You don't have to write out all the numbers. See, you pull out 1. The 3 2's, so you pull out 1. You're still going to get the same answer. 1x. And the y's, it's going to be y to the third, multiplied by y to the third, multiplied by y to the first. Just like I explained this rule, you're just writing it in a different form, but you're still getting the same answer. This rule explains it all. So the 2 y's right there. That's how we get that. And then still it's going to be extras right here. That's how we get this. Now we got this, and we got to put the radicands back. 5x, y. Because 5 multiplied by x is 5x, and 5x multiplied by y is 5xy. That's how we got this. Same thing here. 5xy. And this is our final answer, but not yet. I'll explain why. Because, let me just bring this or down. You get it. I'm just showing you the arrows so you know it could be either or. We are not done because we still have to put the index like I established right here. This index is very important. So you got to put the index and make sure you don't confuse it with the exponents. So you put it up top, up next to the radical sign. As I said here, the terms. You know how I'm using the terms right here. You got to study them because they will be showing up in a test. If you guys take tests, you got to put the index. Remember, index right here. Exponent. This is the exponent. So that's why you don't want to confuse it. Exponent right here. Let me write this out. Exponent. And this is our answer. 2xy squared. Cubed root of 5xy. Thank you very much. And good luck. Study the prime factors. The prime factor tree is very important. This is, if you don't know the prime factor tree, good luck in solving the problems. And you got to know the exponent rule. So that's all I'd study. Let's write that down right here. Prime factor tree. And also the exponents rules. You gotta know them all. The divisions, adding, subtracting. I don't want to go through it all because right now I'm just showing you how to solve this problem. But if you can look at my previous videos, I might have explained it earlier. But to solve these problems, it's just common knowledge because simple problems are they're not hard. Hard problems are simple problems stacked up together. So this is what I would study to solve these problems. These are radical expressions. Thank you, and that's all.